Right. Coming to the next topic. Rules for obtaining images formed by a convex lens. Rules for obtaining images formed by a convex lens. As we discussed, rules obtaining by image by a concave mirror. By a concave mirror. Here we have to discuss rules obtaining images formed by a convex lens. What happened if the light laser passes through convex lens? Convex lens. Let's discuss the first rule. A ray of light which is parallel to principal axis. A ray of light which is parallel to principal axis passes through principal focus. Passes through principal focus. Say in case of concave mirror also, if the light rays are incident on the concave mirror parallel to the principal axis, after what will happen? They pass it through focus. Same rule here. So a convex lens, principal axis. Concave lens, principal axis. Case 1. Principal axis. If the light rays are parallel, to the principal axis. Lagin draw or with help of a double diagram also we have no problem. This is the center. This is the center. So what will happen? If they are parallel to the principal axis, so after they pass through focus. So this is called as a focus. This is called as focus. So here F and here F dash. So here 2F, then here 2F dash. This is the first one. Parallel to the principal axis, they pass through focus. They pass through focus. Then second one. A ray of light. ఒక రే కూడా మనం ఎక్స్ప్లెయిన్ చేసిన నో ప్రాబ్లం బై టేకింగ్ సింపుల్ డయాగ్రామ్. Light incident here, it passes through focus. It passes through focus. Alright. No. Second one. A ray of light passing to the optical center of convex lens goes straight after refraction. So convex lens, principal axis, this is the optical center, this is the optical center. If the light ray is passed through optical center of lens, it goes straight. It goes straight. It goes straight. Then a ray of light, a ray of light passing through focus of a convex lens, pass parallel to the principal axis. So a convex lens, principal axis, this is the center of lens or the optic center. If it is the focus, if the light ray is passing through focus, after the refraction it pass along the principal axis or parallel to the principal axis. One is if it is parallel to the principal axis, after refraction it pass focus. If it is passed through optic center, no deviation, path striking. If it is passed through focus, it after refraction, it travel parallel to the principal axis. Principal axis. There is one special case. There is one special case. Let us discuss what is that. The special case is if light rays, if the light rays or when a parallel rays, when a light rays making some angle, making some angle with principal axis, principal axis. So if it is a convex mirror, this is the principal axis, this is the center of lens. If the light rays make some angle, the parallel light rays make some angle with the principal axis. If it is incident on the lens like this, what is parallel to the principal axis passes through focus. If it is if it is the optic center moving like this, if it is focus, if it is through focus parallel to the principal axis. The special case, if the parallel light rays making some angle with the principal axis and incident on the convex lens, what will happen? So all the refracted rays are converged at a plane. So if for example imagine that a parallel light ray incident and it is the focus. So if it is focus, if a parallel beam of light rays making some angle with the convex, making some angle with principal axis, after refraction, all the rays are converged at a point or diverged. All the rays are converged at a point or diverged at a point from a point lying on the focal plane. So if it is the focus, so where they are all converged, it is focus, they converge or diverge, at a point where the focus is present. Where when it's diverges a point lying on the focal plane. Focal plane is the plane perpendicular to the principal axis. Focal plane is the plane perpendicular to the principal axis at the focus. So focal plane, this is the focus point. Focal plane is the plane perpendicular to the principal axis at the focal. So this complete area we can set to be the complete area we can say to be focal plane. Focal plane. So, if the ray of light parallel to the principal axis passes through focus, if the ray of light is passing to the optical center, goes right. If the ray of light passing through focus of concave lens become parallel to principal axis. If the light rays making some angle with the principal axis, all the rays are converts or appear diverges at a point in the focal plane. In the focal plane is the plane perpendicular. This is the plane perpendicular to the principal axis at the focus. So this is also not given in your textbook. Especially this is. Now, formation of image by convex lenses at different positions. So keep in mind is all. Formation of images by convex lenses at different positions, and the nature also. Formation of different types of images. Formation of images by convex lens at different positions. So as usually, like a concave mirror, we have to place the objects where first one between pole and the focus. Simply here also between optic center and the focus. Then at the focus, then between 2F and F, center of curvature at the focus. Then at 2F, next behind 2F, and the sixth one is at infinity. So in case of concave, we will also discuss like between the pole and the focus, at the focus, between center of curvature and the focus, at the center of curvature, beyond center of curvature, at the infinity. So here also we have considered like this. So F dash, two focus untayi kabatti one. Then first one between the optical center and focus. Between the optical center and focus. So what will happen? Where the image of an object is formed, let us discuss. Right? What is the first one? Between optic center and the focus at C and F dash. Between optic center and focus, what happened? Where the image is formed. Imagine that a convex lens. No need to draw this symbol like this. If you have no problem, also draw. Here also, this one also right. This one also right. As for my convenience, I am drawing like this. So the line joining through principal through center of through optic center. So optic center and focus, where you have to locate the focus. Here it is the focus, F dash. So here F, here 2F, here 2F dash, 2F dash. So condition, to know the position of image, at least required two lighters, If the object is placed, in between optic center and the focus. Object is placed here. As usual, one is parallel to the principal axis. So passing through focus. Then take the one node. The other one is passing through optic center. So these two are parallel to each other. So they cannot meet at any point. To know the position of the image, we have to extend these rays back. So this is the ray and this is the original ray. So the image is formed behind 2F. So virtual erect enlarged image will form behind 2F. The image is formed. Virtual image behind the object on left side of the lens. Behind the object. So behind the object. Behind the object is image is formed. Virtual array larger than the object. Right, larger than the object. So where at or between center of optical center and the focus. This is the first one. Then second case. What is second case? At the focus. What will happen if the object placed at the focus? At the focus. F dash. So principal axis, center of optic center. See here for understanding we have done like this. F dash. So here F object is at here. Here. So first one parallel to the principal axis, pass through focus. Let us take the one more is through the center of curvature, through the optic center, where the image is formed now at infinity. The image is formed at infinity. So real and inverted image uh, form at infinity. Formed at infinity. Formed at infinity. If the object is placed at the focus, at infinity the image is formed, real and inverted, highly enlarged. Highly enlarged image. Highly enlarged image is formed. Highly enlarged image is formed. Then coming to the third one, where between 2f and f. Between 2f and f. So now between f and 2f dash. F dash and f. Lens, convex lens. So it is f dash and it is the 2f dash, optic center. So here f, here 2f. Object is between f and the 2f. F and the 2f. The light ray which is parallel to the principal axis, incident and passed through focus. Then the second light ray which is passing through the center of or optic center. Optic center. So where the image is formed, like this the image is formed. Characteristics are real, inverted, real, inverted. Real, inverted image is formed. Where it is formed, larger than the object. Characteristics is larger than object. Larger than object. Behind 2f. Behind 2f is formed. Behind 2f is formed. Then one more, at 2f. At 2f. At 2f dash. 2f dash. So a convex lens, principal axis, optic center. Here it is focus and it is the 2f1. So it is f and it is 2f. Object is placed at here. Object is placed at here. You continuous ground and రాసుకోవచ్చు no problem. నువ్వు ఉన్నాయి సార్ మన వెంట పట్టుకొని రాలేదంటే ఇలా పెట్టుకోండి, నో ప్రాబ్లం. సింపుల్ థింగ్. We are getting some confusion sir అంటే ఇలా రాసుకోండి. ఓకే. Then what happened if the object is placed at 2f dash. 2f dash. Object at 2f. Object at 2f. So as usual, the light ray which is parallel to the principal axis passed through focus, then through the optic center. Through the optic center where the image is formed here at 2f. At 2f image is formed. So here it is the f and here it is the 2f. 2f. So real, inverted, same size at 2f. At 2f the image is formed. At the 2f is, after the 2f is, image is formed. So if we place at the 2f dash, the object also placed at the 2f dash. Size of the image is equal to size of the object. Size of the image is equal to size of the object. So between f and 2f, one side of the lens real and inverted, smaller than the object. Sorry, smaller than the object. Smaller size. Sorry, same size. Real inverted, same size at 2f form. Same size 2f is form. Then coming to next behind 2f. Behind 2f. So a convex mirror, convex lens, principal axis, optic center. So here f dash, 2f dash, object placed here. So let us take a light ray, it is parallel to the principal axis, passed through focus. Here it is the focus. Then one more, through optic center. Where the image is formed. Here to f. The image is formed between. So drawing the ray diagrams are the very important. So object is formed. Dash 2f dash. So one is a parallel light ray passing through focus. Another one is through the center of focus. So here it is the f and here it is the 2f. The image is formed here. So characteristics are real, inverted, smaller than, so small size, smaller image than the object. So between f and 2f. Between f and 2f is object is behind the 2f. Then at infinity. So a convex lens, principal axis, optic center, if the object is at infinity. So what happens if the object is at infinity? So one light ray which is incident here and passed through focus. Then one more is parallel to the focus. Where that image is formed. Exactly at the focus. The image is formed. So this is the focus. So real, inverted, much smaller at focus. Much smaller at the position of the image is at focus. So between C and F, here C is optic center and the focus. Image is virtual and enlarged behind the 2f1. Behind the object is from left side. If the object is at the focus, the image is formed at infinity, real and inverted, so highly enlarged. If the object placed between focus and the f dash and 2f dash, So the image is formed behind the 2f enlarged, real inverted larger than the object. At 2f1, it is also formed at 2f same size, real and inverted. Behind the 2f and the real inverted smaller image between form f and 2f. At infinity, the image is formed at focus. So these are the different images formed by a convex lens. Different images are formed by the convex lens. Convex lens. Now determine the focal length of convex lens. When the object is at infinity, how do we know the focal length? What is the focal length? The length between or the distance between optic center and the focus. Optic center and the focus is called focal length. To know the focal length of a convex lens, when object is at infinity, the distance of image from the lens will be equal to the focal length of lens. Focal length of the lens means if the object is placed at infinity, the object forms image at certain distance. So that certain distance, if we measure the distance between the point where the image is formed from the optic center, so the length between the optic center, the point where the image is formed, is called as focal length. So the distance between optic center and this point where the image is formed, this is called as the focal point. There are two focal points as usual, f dash, small f and f dash, small f and f dash. Right now, so these are the images formed by convex lens when the object is placed at different object. So these are called the ray diagrams. So practice the ray diagrams. You did not practice the ray diagram, you should not get the proper diagram, proper answer. Practice and practice. So identify the position of the object and identify the image of the object, then the characteristics, real inverted or virtual erector, size of the object same or lesser, more. In this way we have to know the image formed by a convex lens, right? So all this given in a table form. All of these given in a tabular form, so it is very easy to know. Right. The given form, position of an object, then position of image, position of an image, then size of image, size of an image, nature of the image, nature of image, nature of image. So let's take a table form. Object is placed behind f and lens, behind f and lens. Behind f and lens and here convex lens. optic center C, this is the focus and this is the 2F1 to F1. So where we have to place the object first? Between optic center and focus. First one, between optic center and the focus. Between optic center and the focus. Where the image of the position behind the 2F dash or behind object. Behind the object. Behind the object. So enlarged image. Enlarged. Nature of the image virtual and erect. Virtual and erect. This the second one we placed at F dash. At F dash means at focus. At focus. Where the image is for, so at infinity. At infinity. At infinity. So here also form the enlarged image. Enlarged image. So highly enlarged image. Highly enlarged image. So nature real inverted. Real and inverted. Then at between 2F dash and F dash. Focus and 2F. 2F dash and F, where the image is from behind the 2F. Behind the 2F. So behind 2F, enlarged image. Enlarged image. Real and inverted. Real and inverted. Real and inverted. Then at 2F dash. 2F dash. Where the image is from at 2F dash. At 2F dash. So same size. Same size. Real and inverted. Real and inverted. So 1, 2, 3, 4 completed. Then fifth one, where behind 2F, behind 2F dash, behind 2F dash, where the image is formed between 2F dash and F dash, diminished image. Diminished image, real and inverted. Real and inverted. Real and inverted. Then finally at infinity. At infinity, where the image is formed at focus. At focus. At focus. At focus, what will happen? Highly diminished. Highly diminished image. Real and inverted. Real and inverted. Real and inverted image is formed. So this is the tabular form regarding to image object distance and the image distance, size of the image, nature of the image. Nature of the image. So whenever you observe that convex lens forms real and inverted image, except one case, if the object placed between between the optic center and the focus. Optic center and the focus, in those cases it forms a virtual and erect image. The remaining all cases it forms real and inverted image. Real and inverted images only. So keep in mind. Same in case of concave mirror. Between pole and focus, virtual image. At the focus, at infinity image is formed. Between center of curvature and the focus, behind the 2f is formed. Behind the center of curvature is formed. So similar same property. Then uses of convex lens. Uses of convex lens. Convex lenses are used in spectacles to correct the defect of vision called hypermetropia. Hypermetropia. We will discuss what is hypermetropia and myopia, cataract, some other diseases. Convex lens used for making a simple camera. Convex lens are used in making a simple camera. Convex lens used as a magnifying glass or magnifying lens to enlarge the object. Convex lenses are used in making microscopes, telescopes and slide projectors or the film projectors. So used to correct the eye defect called hypermetropia, used in making simple camera, used in making magnifying glass and used in making microscopes, telescopes and slide projectors. So this is about convex lens. So I hope understand this session. So thank you so much.